Welcome to the CopperSpice YouTube channel, and thanks for joining us. Developers like to banter about using templates and the benefits of policy-based design. So let's look at both of these. Template design with policy classes. The theory of policy-based design or policy-based programming came about as the support for templates in C++ improved with the release of better compilers. Policy-based design is a compile-time solution for the strategy pattern. The study of patterns in software design was introduced by the book Design Patterns, released in 1994. It was one of the first books to describe the value of looking at patterns. The objective was to describe how to use design patterns to create flexible and reusable object-oriented software. In most computer languages, the only way to solve the strategy pattern is at runtime. In C++, this is not true. We can solve it at compile time, which is a tremendous advantage. In this talk, we are going to explain policy-based design, how to decide if this approach is the right solution for a given problem, and how to use a policy.
How does policy-based programming compare to other styles of programming? Functional programming is a style which uses only free functions that accept parameters and produce a return value without causing any side effects. Object-oriented programming encapsulates the data and operations as objects. Everything is implemented using classes, inheritance relationships, and methods. Another style to consider is template metaprogramming, which requires more than just writing or using a template. To be considered template metaprogramming, there must be code in the template which makes a branching decision at compile time, based on the arguments passed as the template parameters. Policy-based programming is a technique which combines using a template with something called policies. Using this style of design does not require template metaprogramming. Some computer languages only support one style of programming. For example, Haskell is a strictly functional language and enforces the rules of functional programming. Languages like C++ are more flexible, and it supports all of the styles of programming we've just mentioned. So what is a policy? Basically, it's just an algorithm which is nothing more than a finite set of instructions designed to accomplish some task. A policy is implemented in C++ as a class or a templated class. Policies are specified at compile time. The name of the policy is passed as a template parameter. It is worth mentioning that a policy is not useful as a standalone class. Let's compare a policy to an iterator. Iterators are classes which are very useful and powerful. However, you would never consider trying to use an iterator outside the context of its container, since it would make no sense. The same holds true for a policy. Since we're talking about design approaches, let's look at an example and ask what style of programming is the best choice. Our objective in this example is to design a class which contains entries of a directory listing based on a set of options. Should the entries be sorted alphabetically in ascending or descending order? Are hidden files included? Will the result contain files from the current folder or all subdirectories? It's clear the design needs to handle every combination of the options. As a responsible programmer, we also need to think about how the design will handle other permutations, which might be added later on.
Our first approach uses multiple classes, with one class for each combination of options. Since each of the three options has two possibilities, we need 8 unique classes. This may require duplicated code, and maintenance will be tedious. Naming the classes might also be awkward. The object-oriented design uses a single abstract class and 8 child classes. This is a bit better since we refactored the code and there will be less duplication. The object-oriented approach will still be difficult to maintain, and if the number of options increases, the number of child classes goes up exponentially. What about using a template? Even though no data types will be passed, the template needs to know which options should be turned on and which should be turned off. This can be done using non-type template parameters to pass 3 Boolean values. Having the options evaluated at compile time is an advantage. Only the necessary classes will be generated. The template can be a templated class or a templated function. The methods of the class or the body of the function need to implement the code to handle each option. Oddly, this approach has the same problem of maintainability. So let's consider using policy-based design. With this approach, we implement one template which accepts 3 unique policies as template parameters. Since a policy is the name of a class, each policy class will be responsible for one part of the overall solution. The classes can range from very simple to extremely complicated, depending on what the programmer of the policy class wants to implement. We think this is the best solution, providing the most flexibility and overall readability.
Now we want to show how you invoke a template which accepts a policy. One of the most common examples of policy-based design is from the C++ standard library. The std map container has 4 template parameters. The first 2 are data types, and the last 2 are policies. You are required to pass the key and the value. Both the compare and the allocator template parameters have defaults and are not required. The default implementation for the compare policy is a template class which is in the standard library. It is called std_less, and it compares elements using the less than operator and places the keys in ascending order. The allocator parameter indicates how the container should acquire and release memory. By default, the standard allocator is used, which simply calls the new and delete operators. The advantage of using policy-based design removes hard-coded decisions from the template in favor of classes which can be specified at compile time. Using this example, a programmer can create an unlimited number of compare policies, and by passing a particular one, change the entire behavior of std_map. For more information about the CopperSpice project, please visit our website at www.copperspice.com.
Thanks for watching. We hope you found the content of value. If you have any questions or feedback, feel free to leave a comment on this video or send us email.
Please make sure you subscribe to our YouTube channel and come back for our next video.